Welcome to a tech talk on performance-related best practices for Amazon Redshift. Data is growing exponentially. Coming from new sources is increasingly diverse and needs to be securely accessed and analyzed by any number of applications and people. Amazon Redshift is a fully managed, petabyte-scale, massively parallel data warehouse that helps tens of thousands of customers collect, manage, and analyze that growing amount of data. In this tech talk, get an update on the best practices for Amazon Redshift from AWS Principal Solutions Architect Matt Skayer, Tarun Chowdhury, Data Warehousing Solutions Architect, and myself, AWS Principal Product Manager Paul Lapis. We will share the top 10 most common performance-related opportunities for Amazon Redshift with concrete guidance and demos on how to adopt them. In this Tech Talk, you will learn about what's new with Amazon Redshift that makes it easier to manage and maximize performance, learn how to apply the most common performance enhancing techniques, and then learn how to best scale to handle different workload patterns and business needs. First, let's talk about why customers choose Amazon Redshift. Amazon Redshift has the most customers and is proven for large data warehouse deployments. Tens of thousands of customers collectively process over 2 exabytes of data every single day with Redshift. And for use cases involving hundreds of terabytes of data or more, Redshift is the proven solution for analytics at scale. We benefit from the fact that our friends at Amazon Commercial use Redshift for one of the largest analytical deployments on the planet with 500 petabytes of data in their Redshift clusters. So as we've discussed, adopting a data lake-based architecture for your analytics will help you tap into all of your data. You can take advantage of or be ready to move to evolve to data lake, data sharing, real-time analytics, ML/AI use cases without re-architecture because Redshift is fully integrated with your data lake. And it's the only cloud data warehouse that allows you to analyze any size of data in your Amazon S3 data lake with no loading, duplication, or ETL. Redshift is the world's fastest data warehouse, and it keeps on getting faster. Continuous performance improvements and optimizations have made Redshift 10 times faster than it was just 2 years ago. This is possible because of the lessons learned from processing over 2 exabytes of customer data every single day. Amazon Redshift's hybrid architecture has also accelerated performance. Shared storage provides the ability to scale to unlimited concurrency, while Redshift's on-instance storage provides low latency access to data that can't be achieved in any other way. Redshift delivers 3 things that our customers consistently tell us matter the most when it comes to cost. The first is usage-based pricing instead of license-based pricing, so that you can get started easily, start small at just 25 cents per hour, and scale up to 1 terabyte for just under $1,000 per terabyte per year. Number 2 is great value as you scale your data warehouse. It's the only data warehouse that provides reserved instances, which save up to 75% compared to on-demand prices. Finally, you get predictable month-to-month spending with no hidden charges or surprises. Unlike other cloud data warehouses where you need premium versions for additional enterprise capabilities, Redshift's pricing includes built-in security, data compression, backup storage, and data transfer. Redshift clusters scale from 128 gigabytes to 8 petabytes of storage. Resizing is completely managed by AWS, and there's no limit to how often or by how much a cluster can scale. Security. AWS has comprehensive security capabilities to satisfy the most demanding requirements, and Redshift provides better security out of the box at no extra cost. Finally, Redshift is fully managed. It's simple to set up and operate, and most administrative tasks are automated, such as backup and replication. It has automated backups. It's fault tolerant and provides flexible querying. It also automatically performs maintenance tasks to organize and sort data. It automatically maintains statistics to support query optimization, automatically chooses table distribution styles and sort styles, and adds clusters as concurrency demands increases. Amazon Redshift is the most popular cloud data warehouse. It was first in the cloud and launched in 2013. It's the world's largest cloud data warehouse service that collectively processes over 2 exabytes of data every day from tens of thousands of customers. And our customers benefit from this scale because we work to identify the largest opportunities for improvement based on a constant analysis of usage patterns. For example, Yelp launched an initiative to reduce their time to business insight. They leverage Amazon Redshift Spectrum to query data in place in S3 and dramatically reducing their time to insight to seconds and providing a richer and more interactive experience to their various teams. Fox processes over 100 terabytes of data per day and over 25,000 queries per day. They had a legacy data platform that struggled to scale, faced many outages, and had changing requirements from consumers who had many options. By adopting an AWS Lakehouse approach with S3 as a data lake, Redshift, and EMR as analytics engines to process data, they were able to save 15 to 20% in overall costs versus on-premise, with a 30% improvement in performance. Now, let me hand it over to Matt, who has worked with a number of these customers in the past, to continue talking about our best practices for performance.
Thanks, Paul. Yes, indeed, a lot of familiar names there. One of Redshift areas of focus has been additional automation and better default settings to get great out-of-the-box performance. And we'll touch on some of those elements as we go today. Additionally, you can also do other techniques to personalize Redshift for your own unique use case. After working with several hundred customers over the last few years, I've noticed some patterns from customers who are pushing their Redshift clusters to accomplish new missions or to get every last drop of performance out of their investment. When we talk about performance today, we're talking specifically about getting the best price for performance ratio for your workload. The performance tip that's top of mind to me is where I've seen customers using Elastic Resize for planned changes to the workload, either an increase or a decrease in workload. And we'll describe Elastic Resize more in a moment. For surprise or anticipated increases in workload, that's concurrency scaling's job. You set the concurrency scaling at the workload management, also known as the WLM queue grain. That means you may pick and choose which queues get to use concurrency scaling. For example, you might enable concurrency scaling for a WLM queue servicing a dashboard or a WLM queue for your critical reports. Conversely, you may choose to not enable concurrency scaling for lower priority or less time critical workloads, such as ad hoc queries. This ability to pick and choose is a differentiator for Redshift. We'll also talk more about concurrency scaling in a minute. Elastic Resize adds or subtracts hardware from your existing cluster. I've seen customers using this to size up their cluster for month or quarter end processing, or to reduce their footprint for nights, weekends, or holidays, while still maintaining a desired level of performance. The net of this is that I'm finding customers sizing their clusters with much more focus on their regular steady state usage than on preparing for any peaks of usage that they can anticipate. While you can use the console, the API, or even the CLI to perform the resize, I did want to highlight that we've added a scheduler for Elastic Resize into the console itself. Here's a screenshot I took of it, and it's quite flexible, allowing you to change the number of nodes or even the node type. Being able to pick the day of the week and the hour are sort of obvious use cases, but we've also added targets such as the last day of the month or even the first day of the month, explicitly for use cases I described a few moments ago. Finally, if you're already using Elastic Resize and running it out of cron, you can flip the UI to accept your cron tab syntax for easy migration to the scheduler. Concurrency scaling automatically adds and removes capacity to handle unpredictable demand from thousands of concurrent users. Each concurrency scaling cluster has the same power as the main cluster, and then out of the box, you can add up to 10 additional concurrency scaling clusters. Every Redshift cluster comes with 1 hour of free concurrency scaling usage per day the cluster is running, which from our analysis will mean that concurrency scaling will come at no cost to almost all of our customers. Every customer, even those with the spikiest workloads, will immediately see greater processing capacity at lower costs with a more predictable spend. And I wanted to highlight the predictable spend portion for a moment. We've also added a cost control UI to the console. Using the interface, you can create additional logging entries or even pause usage of the feature at whatever resolution you'd like. So you have complete control over your concurrency scaling spend. One of the handy features of the cost control UI is that you can specify SNS, a simple notification service topic, for any threshold you'd set up that's encountered. This saves writing or provisioning your own notification engine, whether that's using email or text messages. As an aside, This is also the UI where you can perform similar cost control actions for Redshift Spectrum, which we'll talk about soon. Now we're going to switch over to Tarun, who's going to do a quick demo of concurrency scaling.
Thank you, Matt. Hi, my name is Tarun Chaudhary. I'm a data warehouse specialist solutions architect. I'll be demoing the concurrency scaling capabilities of Redshift. So for the purpose of this demo, I'm using a RA3 4XL 5-node cluster, and I'll quickly show you, as Matt has mentioned in the previous slide, that we need to enable concurrency scaling on the queue that we want concurrency scaling to be active on. And this is auto. All you need to do is just turn, go. So as you can see, there's an extra parameter group I have, not the default one. So in the demo parameter group, I have enabled it as auto. You cannot change the default parameter group properties. That's why you need to create a extra parameter group, additional. So you can see the number of max concurrency cluster is 10 there. And what that means is I can go up to 10 concurrency scaling clusters. Let's just quickly look at the cluster if there's any activity going on in the cluster at this point. So there's nothing running, no queries running. So this cluster is the data in this cluster is TPCDS 100 terabytes data, and the benchmarks are the queries that we will be running on this cluster today to check the concurrency scaling capabilities are TPCDS complex long-running queries. So here's a look at these queries. So these are about 2,000 queries that we have in this file. And the utility that I'll be using for this demo is called Power pSQL to run these queries parallelly on our Redshift cluster. Here using the command line, I will kick off the tests and we'll come back in about 30 minutes to see the progress of concurrency scaling. Meanwhile, what I can do is I can quickly show you once after hitting the enter button on the test, you'll quickly see that so many queries are pouring in. As you can see, there are so many queries are coming into the cluster, and these are all running parallelly. While we wait for the concurrency scaling results to come back in 30 minutes, I can go over our next slide, which is about materialized views and how to use them in Redshift. Materialized views provide significantly faster query performance for repeated and predictable analytical workloads, such as dashboarding, queries from BI tools, and extract load transform data processing, or ETL data processing. With the help of materialized view, you can store the pre-computed results of queries and efficiently maintain them by incrementally processing the latest changes made to the source tables. Subsequent queries that are referencing the materialized views use the pre-computed results to run much faster. And with the help of a simple refresh command, you can refresh a materialized view. Furthermore, materialized views make it easier to migrate to Redshift and allows secure access to the pre-computed results. Next, let's see a demo about materialized view in Redshift. How can you create them and how can you refresh them? For this demo, I'm using a SQL client. I'm connected to my Redshift cluster, and I can see the tables that will be used for this demo: customer address, customer, and product reviews. So these tables are essentially product reviews contains customer reviews for a specific product, while customer contains customer profile data, and customer addresses contains customer address information. So this is the materialized view definition. What we are trying to do here is in this materialized view is to pre-compute the count of reviews per product category and per state. In order to achieve that, we are joining product reviews, customer and customer address table, and then grouping on the basis of product category and customer state. So once the materialized view is created, let's just run some queries on top of it. So this one particular query is aggregating on the grain different than materialized view. Materialized view is have product category and state. What I'm trying to get here is customer reviews on the basis of customer state and see how quickly that query runs. Next, let's just insert some data into one of the base tables, and later we'll run a refresh command that will refresh the materialized view on the basis of the changes that happened to that product reviews table. So here I'm simple command refresh materialized view and the name of the materialized view, and we're going to run this command. The refresh command will refresh the materialized view only for the changes that were happened, or only for the insert statements or the inserts that I did in the product reviews table. So the materialized view is refreshed, and this concludes our demo. Now I'll hand it over to Paul for the next part of the presentation. Thank you.
Thanks, Tarun. Now I wanted to switch gears for a second and talk about the Amazon Redshift Advisor. Redshift customers have asked to make Redshift easier to use by eliminating the need to perform routine maintenance tasks and performance optimizations like applying sort and distribution keys to tables. Over the past few years, Redshift has invested heavily in automation and the Advisor. The Advisor is a free tool for Redshift customers that continuously monitors cluster workloads and applies advanced AI techniques to recommend specific actions to tune Redshift to improve cost and performance. Over 75% of clusters have at least one recommendation, so I highly recommend that you log into your console, click on the Advisor tab to view your recommendations for your cluster. Now, the Advisor develops its customized recommendations by analyzing performance and usage metrics for your specific cluster. So the recommendations are personalized for you and the workload and the data that is running on your cluster. And so to help you prioritize the optimizations, the Advisor also ranks the recommendations by order of impact. The Amazon Redshift Advisor provides a rich set of recommendations for your cluster across the categories of data ingestion, query tuning, and table optimization. For data ingest, it will look at all the copy commands running on your cluster and identify opportunities to speed them up or to optimize them to increase throughput of data loading into the cluster. For example, it will recommend whether or not the data should be compressed in S3 to speed up copy times, or whether it makes sense to split up the S3 files into multiple parts to take advantage of the parallelization of the copy statement. For query tuning, the workload manager will be evaluated to identify opportunities to reduce memory consumption and increase throughput by enabling features like short query acceleration. And for table optimization, the Advisor will look at how queries interact with your data to make recommendations for applying better sort keys or distribution keys to your tables to speed up joins or table scans. It will also identify ways where you can modify the compression encodings of columns in order to speed up those queries as well. Now, the Advisor provides recommendations for the manual workload manager feature. However, Amazon Redshift has an automatic workload manager feature that that was recently launched that makes it much easier to optimize the workload manager. And Matt can share a little bit more about how Auto WLM works.
Thanks, Paul. Many of my customers are using Auto WLM nowadays, which has unlocked greater throughput as the usage pattern changes throughout the day, week, or even the year. So if you're using manual WLM now, I encourage you to try Auto WLM, particularly if you're thinking about changing its configuration to accommodate day, night, or weekend workloads. And if you're new to Redshift, I'd suggest just going straight to Auto WLM. With Auto WLM, you can define queues such as ETL reporting, dashboards, data science, etc., and assign a relative priority to each. This is just a simple term such as low, medium, high, and highest. That's it. Redshift will handle the rest. Behind the scenes, automatic workload management uses machine learning to dynamically manage the memory and concurrency to help maximize query throughput. By setting the query priorities, you can ensure that higher priority workloads get preferential treatment in Redshift, including more resources during busy times for consistent query performance. Automatic WLM uses intelligent algorithms to make sure that lower priority queries don't stall, but continue to make progress. You can also enable concurrency scaling for any query queue to scale to a virtually unlimited number of concurrent queries with consistently fast performance. So you can use Auto WLM and concurrency scaling together. The next really important area is to talk about taking advantage of the data lake. To realize the value of data, customers are increasingly moving to data lake architectures. Amazon Redshift is focused on the ability to live inside your greater data architecture that includes a data lake. This means you get your relatively static business data optimized in a data warehouse with all the benefits of a traditional data warehouse that's fast, easy to set up and use. And Redshift is special because it's the only solution that gives you 1 foot in the data warehouse and 1 foot in the data lake. So this is our data lakehouse. Amazon Redshift is the only data warehouse that extends your queries to the S3 data lake without moving or transforming data. Now with writable external tables, which we'll talk about in a moment, you can also save the results of a query you have run in Redshift into your data lake in a Parquet format, so you can analyze that data with other analytic services such as SageMaker, Athena, and EMR. Of course, with the benefit of being part of the AWS analytics ecosystem, Amazon Redshift is natively integrated with these other services. You can use lake formation to create your data lake fast, in days instead of weeks, and benefit from security, access control, and more. AWS Glue can extract, transform, and load data into Redshift, and Amazon Kinesis Data Firehose is the easiest way to capture, transform, and load streaming data into Redshift for near real-time analytics. And finally, you can use Amazon QuickSight to create reports, visualizations, and dashboards. So now let's look for a moment at Spectrum. So Spectrum launched a couple of years ago. And so this is a feature that creates a layer that sits between your compute nodes and S3. That's what powers our lakehouse approach to data warehousing. So you can store data in S3 in an open formats like Parquet, JSON, and Avro, and expose that data in S3 to your Redshift cluster as an external table, and then query it with the Spectrum layer with compute that's spun up dynamically at query time. You can even join the data in S3 to your cluster, so it makes integration with the data lake that much easier. Some customers are also offloading data to reduce the footprint of their cluster themselves. One of the more recent enhancements we've made to Redshift is using the materialized views that Tarun just demoed that now can cover Spectrum as well. So the common patterns I see in the field are, simply a query that your user doesn't need to know whether the data resides on Redshift direct attached storage or on Spectrum. But another pattern I see that's quite popular is simplifying your ETL with sort of an insert select from a Spectrum table pattern. This has the useful benefit of leveraging that off-cluster compute layer to quickly process the job. An additional element for this is the addition of the writable external tables. And this takes the efficient, massively parallel unload functionality and adds automatic partition management onto S3 there. And there are 2 main ways you see this invoked. One is to simply use create external table as select. So you have your query and just creates the external table for you. And the other one is for an existing external table just to insert into that external table. So very convenient syntax, probably very familiar to all of you. Then we've extended the analytics from Redshift into the relational database world. With the federated query capability in Redshift, you can query live data across S3 as well as 1 or more Amazon RDS or Aurora Postgres databases and get instant visibility into the end-to-end business operations with no data movement. This allows you to augment your data warehouse with new data sets in one easy step without having to set up and maintain complex ETL pipelines. You can enrich the insights by joining this data from your Redshift data warehouse, data in your data lake on S3, and now data in your operational data stores in Postgres to make better data-driven decisions that matter to your business. Redshift automatically applies optimizations to reduce the amount of data moved over the network and complements it with a massively parallel data processing to enable high query performance experience for users. This is another spot where you can use materialized views to cover a federated query. And this is a really interesting pattern to give your users a view that has everything all at once. Tip number 6 is using query monitoring rules from workload management and Amazon CloudWatch metrics to drive additional performance improvement. While Redshift's workload management defines the lanes of traffic through the cluster, it's really important to establish the rules of the road with the query monitoring rules. In the field, just about every production cluster I've run across is using QMR to a lesser or greater extent. Here are a few screenshots I captured. Similar to how concurrency scaling can be permitted at the WLM queue level, query monitoring rules are also set up at that WLM queue grain. This means that you can limit the number of rows sent back to a dashboard to less than 20 million rows, for example, or the amount of time jobs running in the intern queue can execute. So an example of the query monitoring rules is the screenshot on the right there. To make this process as easy as possible, we've made QMR templates that you're welcome to use and even modify. And that's a screenshot from there. So you can just click and select those and modify them if you choose to. And then the CloudWatch metrics are a really valuable data set and pre-existing visualization that I see tons of customers taking advantage of. This sort of the way that I view those, there's kind of a taxonomy. So there's the metrics, which are sort of the fact data, and that's down at the network level, at the IOPS level. That shows you query throughput and even quotas. You know, we have quotas now available in Redshift. And the other part to this that complements that is the dimensions. And so that's the compute node or the leader node, the different query states, the different query priorities, and the WLM queue. So you can combine those fact and dimensions together and really have powerful insights into your data. Being able to see this on the dashboard automatically, I see widely used as I visit customers. And also being able to query for this data is also a useful skill to have. And I did want to highlight as part of this that the query monitoring rule data set is another valuable resource that is being populated continuously, whether you've set up QMR rules or not. Okay, so now let's check back in with Tarun and see how things are going with the concurrency scaling demo.
Thanks again, Matt. So just a quick recap, we ran a concurrency scaling test on a RA3 4XL 5-node cluster with 100 terabytes of TPCDS data using some long-running TPCDS queries. And some of the things that we need to take a look here is how we use the concurrency scaling clusters and how did the queries perform, what's the query throughput looks like. So in the Redshift console, under the query monitoring tab, if we click on the workload concurrency, it'll open up the charts or the monitoring metrics related to the concurrency scaling. So if you look at the concurrency scaling activity, and first of all, if you look at the queued versus the running queries per queue, they were at the peak of it, there were like 2,000 queries running. And it started small with below 100 queries, and then it went up all the way to 2,000 queries. Meanwhile, when Redshift realized that there is a backup of queries in a particular queue, it started spinning up concurrency scaling clusters. So there were 10 concurrency scaling clusters spun up and used by Redshift at that time. The concurrency scaling usage was about 375 minutes at the same time. Next, just take a look at the database performance to see how our queries perform, what the query throughput looks like. So in this tab, if you look at the queries by duration range, the green bar shows that there were mostly long-running queries that were executed in this test. In the next chart, which is query throughput, at the peak of it, there were around 3 queries, and we are talking about the long-running queries here. 3 queries per second were executed on the cluster, which means that a throughput of about 180 queries per minute. And that is provided by the concurrency scaling capabilities of Redshift, where Redshift spun up 10 additional clusters and offloaded the queries that were queued up on the main cluster to those concurrency clusters to be able to achieve this high throughput of 180 queries per minute. And this concludes our demo. I'll hand it over to Paul. Thank you.
Thanks, Tarun and Matt. In this tech talk, we learned about what's new with Amazon Redshift that makes it easier to manage and maximize performance, and how to apply the most common performance enhancing techniques. To learn more, visit the AWS Big Data blog to view these top 10 performance and best practices for Amazon Redshift and additional content around AWS Analytics, or view the Amazon Redshift documentation or the Redshift videos. If you're new to Amazon Redshift, the set of short videos will show you how to get started on Amazon Redshift and its features such as materialized views, fitted-ready query, cost controls, and pause and resume. If you're already using Redshift, great. We wanted to offer you a free Redshift optimization session. Feel free to reach out to your account team for more information on that. And if you're just getting started with Redshift, ask your account team for a quick 10-minute demo of Amazon Redshift, or to learn more about how to do a proof of concept on your own or get help, follow the links in this slide. Thank you.